Linear.
Hello, good evening. I'm Madam Monica, ready to present you with a presentation on memory management. Memory management is the process of controlling and coordinating memory resources in a computer with an objective of optimizing system performance. The process involves assigning portions or blocks to running application. Memory management tracks all memory allocations and decides how much memory is to be allocated to processes. Functions of memory management. Function 1 is keeping track of which parts of memory are currently being used and by whom. 2. Deciding which processes are to be loaded into memory when memory spaces becomes available. Allocating and deallocating memory spaces as needed. We have definition of terms such as memory management unit, a hardware that performs memory management, tasked with caching and virtual memory operations. It resides in the CPU. Physical addresses identifies the physical location of requested data in the memory. The user accesses the physical address through its corresponding logical addresses. Logical address is a physical address equivalent that is assumed by a host that is used as an executing application. We have contiguous memory. This is a memory allocation technique that characterized by an assignment of memory blocks to a process in a consecutive manner. It's an old memory allocation scheme. Paging, a memory management technique where the unit of measurement is pages. The address space is partitioned into pages. Paging play an important role in the implementation of virtual memory. We have swapping. It's a memory management technique where some processes are temporarily moved out of the main memory to the disk to allow other processes to be executed, upon which they can be recalled back. Segmentation. A process is divided into several modules of different sizes called segments. The segments perform the same function but bear separate addresses. Partitioned allocations divides the RAM into multiple partitions, often using a contiguous scheme. When the process starts, it's allocated a partition, and when deallocates, when it stops. Overlay useful when running bigger programs than the available physical memory. It's a concept that uses some parts of the program that is running only other than loading the whole program. It helps reduce memory burden. Virtual memory emulates a computer RAM. It allows a computer to address more memory that is actually installed, which will enable us to extend the use of physical memory. Memory allocation techniques. Definition of a memory allocation. Memory allocation is the process of assigning block of memory on request. Typically, the allocator receives memory from the operating system in a small number of large blocks that it must divide up to satisfy the request for smaller blocks. Classifications of memory allocation schemes. We have contiguous memory allocation. Contiguous memory allocation, all the available memory space remain together in one place. It means freely available memory partitions are not scattered here and there across the whole memory space. In the contiguous memory allocation, both the operating system and the user must reside in the main memory. The main memory is divided into two portions. One portion is for operating and the other is for the user program. we have the non-contiguous memory allocation. In the non-contiguous memory allocation, the available free memory space are scattered here and there. All the free memory space is not at one place. So this is time consuming. You will read for yourself the remaining. Types of allocation techniques. Swapping. We have swapping. Swapping is a mechanism in which a process can be swapped temporarily out of main memory to secondary storage and make that memory available to other processes. At some time back later, the system swaps back the process from the secondary storage to main memory. This is done to free up available memory. Swapping is necessary when there are more processes than available memory. In the figure below, we have it shows how processing is done. Process 1 is swapped out into the secondary storage and process 2 is swapped into the main memory as shown below. As you can see in the diagram, operating system, we have process 1, process 2, parking store, user space, main memory. So process 1 is swapped in, then process 2 is swapped. Process 1 is swapped out and process 2 is swapped in. That is maybe after processing it's processed back, that is it's swapped into the memory. Next, we have paging. The term virtual memory is usually associated with systems that employ paging. Each process has its own page table. Each page table entry contains the frame number of the corresponding page in the main memory. In computer operating system, paging is a memory management scheme by which a computer stores and retrieves data from secondary storage, e.g. hard disk, for use in memory. Paging is a process whereby physical memory is broken down into fixed size blocks called page frames. Logical memory is broken down into blocks of the same size. Diagram illustrating paging. We have page 0, page 1, 2, 3 in the local memory. Then we have 1, 4, 3, 7, that is the page table. Frame number, we have frame number from 0 to 7. Then we have page 0 located in frame number 1, page 2 located in frame number 3, page 1 located in frame number 4. Then we have page 3 located in frame number 7 of the physical memory. Second diagram illustrating paging. Paging, we have CPU there, logical address. In the logical address, it's been allocated 2 letters, BD. Then physical address there, it's been allocated FD. Then we have physical memory. Then the page table, which is assigned letter T. Explanation of paging. Every address generated by CPU is divided into 2 parts, page number and page offsets. So the letter P there, it's assigned for page number, then page offsets is assigned letter D. P is used as an index into a page map table. Let page size be equal to 4 bytes and available physical memory be equal to 32 bytes, where we therefore have 8 frames and 8 pages as follows. Page 0 addresses 0 to 3, page 1 addresses 4 to 7. As shown there, that is further explanation on pages and the addresses. That is page 2, addresses 8 to 11, page 3 addresses 12 to 15, page 4 we have addresses 16 to 19, page 5 addresses 20 to 23, page 6 addresses 24 to 27, page 7 addresses 28 to 31. When a process is to be executed, its pages are loaded from the parking store into any available memory frames. In these schemes, the operating system retrieves data from secondary storage in same size blocks called pages. So main memory is called RAM and secondary memory is called the disk. Translations of addresses. At the compile time, we have the primitive. We have compiler generates physical addresses, requires knowledge of where the compilation and unit will be loaded, rarely used Microsoft DOS. We have segmentation. Segmentation refers to the technique of dividing the physical memory space into multiple blocks. Each block has specific length and is known as a segment. Each segment has a starting address called the base address. The length of the segment determines the availability memory space in the segment. When a process is to be executed, its corresponding segmentations are loaded into non-contiguous memory, though every segment is loaded into a contiguous blocks of available memory. Segmentation memory management works very similarly to paging, but here segments are of variable length, whereas in paging, pages are of fixed sizes. This is the illustration for segment map. The segment map table, we have ZB. The size space access are shown below. There is size of 1000, base of 1000, and so on. OS, we have, that's operating system. We have segment 0, segment 4, segment 1, 2, segment 3. That's unoccupied, which means they are free. Types of segmentation. We have virtual memory segmentation. There is symbol segmentation and others. To explain on virtual memory segmentation, each process is divided into a number of segments, not all of which are residents at any point in time. Simple segmentation. Each process is divided into a number of segments, all of which are loaded into a memory at runtime, though not necessarily contiguously. Continuation on the segmentation. There is no simple relationship between logical addresses and physical addresses in segmentation. A table stores the information about all such segments and is called a segment table. Segment table, it maps two-dimensional logical address into one-dimensional physical address. It's each table entry as base address. It contains the starting physical address where the segment resides in memory. Limit, it specifies the length of the segment. Advantages of memory allocation. Allow the capacity to be 1 MB even though the address associated with the individual instructions are 16 bytes. Allow the use of separate memory areas for the program code and data and stack portion of the program. Permits a program and or its data to be placed into different areas of memory whenever the program is end. Multitasking becomes easy. The advantage of having separate code and data segment is that one program can work on different sets of data. This is possible by reloading the data segment register to the new data. The reference logical address can be loaded into the instructions pointer and run the program anywhere in the segment memory as the logical address varies. Programs are relocatable so that programs can be run at any location in the memory. I think I will stop there for today. I want you students to look on disadvantages of memory segmentation, advantages of segmentation, partition allocation, and partition allocation schemes. We have fixed partition allocation scheme. We are going to look at that next time when we meet. Thank you for your time. See you.